So, what? No.
No?
Yeah, sure. What's your question?
I was just going to ask what the favorite color was.
Pink. Neon, preferably.
Neon?
Yeah. I love all things neon. Okay. So let's see. We talked about 8.3 a bit. There's more of that in that video. So there's a couple more examples fully worked out in there. So if you want to play with examples, go check out that YouTube video. We did the easiest one. There's 2 harder ones in there, I think. So feel free. Let's see. Let's talk about 8.4 a bit. We're going to blaze through things today because we set up a bunch of framework with this function talk we did over the beginning of the semester. So now we're going to learn some new functions. Okay. So we already learned lines, right? We learned absolute value. Now we're going to learn quadratics, which are just parabolas that we've already talked about, right? Okay, so there's not too much new stuff here. Okay, so a quadratic function looks like the kind of thing you jam into what? Yeah, into the quadratic formula, right? So a quadratic function is one of these guys. Maybe let's call this thing Q for quadratic. So a quadratic function of x is an ax squared plus bx plus c. Okay? No. So if I want to find the zeros of a quadratic function, I use the quadratic formula. Does that make sense?
So we're not using the function, we're not using the formula, we're using the function.
Yeah, so this is a category of function, right? These are a kind of function. So they're sort of a rule, right? They go from numbers to other numbers. That's really what there is. Okay? So if we want to find zeros, so if we want to solve q of x equals 0, we use the quadratic formula. Okay? Yes? Good? Okay. Let's maybe draw some examples of graphs and then ask the kind of obvious question, maybe. Okay, so here's some examples of graphs. What's the basic thing like this? What's the maybe easiest thing you can get that looks like this? Okay, you guys probably aren't used to thinking in A, B, and C's, right? This is like super wildly confusing. Okay, so how about answer me this? Is f of x equals x squared, is that one of these? Yes, it is. How do you know it's one of these? So what are the A, B, and C for this one?
It's the A.
1, B is 0, C is 0. You guys see that? So this is a quadratic function, right? With A is 1, B is 0, C is 0. I should probably add this caveat before I screw things up. A can't be 0 for this. If A is 0, what is this thing?
A line.
Yeah, then it's a line. It's not a quadratic function. It's something simpler. You guys see that? So I'm going to need A to not be 0 for me to call this a quadratic function. If A is 0, it's a line. We already know how lines act. We had a whole section on lines. And we all fully understood it. I know that's a little bit ambitious, but I'm hoping you understood it at least a little bit and you recall some things about lines. These are a little different. What does the graph of this one look like?
Parabola.
Yeah, it's a parabola, right? This one opens upward. Why does it open upward? Because the A is positive. See that? Because the A is positive. There's a good reason for this. It's really that when I put in big numbers, right? When I think about what happens if I cram a really big number into something like this, for the x, right? Well, I get A times a really big number times itself, which is a humongous number, plus B times the number, right? Which is no longer even big in comparison to this other thing, plus C, which is probably like really small. Okay, see that? For instance, if I put in a million here, right? I get an A times a trillion plus B times a million. Trillions are way bigger than millions, right? So this is kind of the dominant term, which means that in the end, right, as I move way out right, that A, if it's positive, gives me a big number back. If it's negative, it gives me a big number that's negative. You guys see that? So if the A is positive, the thing points up. If A is negative, it points down. This is a really nice trick to know. Because why? What do I know about the vertex if it points up? Okay, first, where's the vertex on this one? Yeah, it's at the origin. It's this point here. That's the vertex. And because it points up, this is a, you guys don't know this word yet, minimum.
What?
Minimum, it's the bottom, right? It's the smallest the function values ever get.
And that's only because it's pointing up.
Yeah, because it's pointing up, right?
Okay.
In this case, it's a minimum. If I had a different picture, like say g of x was minus x squared, this one looks like a parabola pointed downwards. How do I know it's pointed downwards? What's the A for this one? Negative 1, which is less than 0. Okay. What are the B and C?
Okay, what, can somebody tell me?
So I'm thinking A is negative 1. And then are there any x's here in my formula? There's squares, right? There's x squareds, but are there any plain x's? No, so B is 0. Are there any constants that I'm adding? No.
Hey, can somebody tell me why this A is 1 and B is 0 and C is 0?
Yeah, guys.
There's nothing there.
So the B and C are 0 because there's nothing there. The A is negative 1 because there's a negative x squared. Does that help? Okay. So now, where's the vertex on this one? Still at the origin, right? But what is it now?
Oh, because it's the highest.
Yeah, it's the highest point, so now it's a maximum.
Oh, okay.
You guys see that?
Yes.
Minimum's the lowest point, maximum's the highest point. Cool? Okay, so the entire discipline of calculus is developed basically to find these things. Minimums, maximums. Okay, but we have a way to do this for quadratic functions with what we know. Okay? My claim is we can already find these vertices. So let me throw another couple pictures up here. So keep in mind, they don't have to go through 0, 0. This could be one. Okay? What do I know about this one?
It goes up.
Goes up, so what's the A? Yeah, A is positive. You guys see that? I don't need to know anything else about this. I know that if the A is positive, what do I know about the vertex? The vertex is a
Minimum.
minimum.
It's still below the x-axis though, so would there be negative?
Yep, so there's the output, right, that's associated with that is a negative number,
Okay.
which means that maybe my minimum profit is a loss or something. That can happen. We have interpretations for negative numbers sometimes, right? So that's a minimum, and that's our vertex this time. We had another one. Sometimes they look like this. What do I know about the A here?
Negative.
A is negative because it points down. What do I know about the vertex? Yeah, the vertex is a maximum. What's the output associated with this vertex? Yeah, what do I know about the output associated to the vertex?
It's going to be negative.
Yeah, it's going to be a negative number. That might mean the best I can do with this situation is take a loss. Okay, see that?
And is that how you want them labeled as A is less than 0, A is greater than 0?
Yeah, I'd like you to be able to identify that. And then this is, yeah, this is just me giving you some examples of what things can look like.
So the output would be negative.
Yeah, so the output associated with this maximum value is negative.
Okay.
Cool? So let's figure out how to find the vertex. We can actually do this. We have a tool for this. I don't know why I'm capitalizing random words. How to find a vertex. And ID it as a max or min. One of these is easy, right? How do I ID it once I've found it? Yeah, I check whether A is positive or negative, right? If A is negative, that means the parabola opens down, so I get a max. If A is positive, I get a min. So this piece at least is easy, right? A bigger than 0 means minimum. A smaller than 0 means maximum. Okay, so that part should be easy. Okay, that's opening up or opening down. All right, so now how to find a vertex at all is a bit weird. Okay, so let me give you a statement first. The vertex is at x is negative b over 2a. I would claim you don't really have to memorize this. This comes from somewhere really reasonable. Where does this thing come from? From the quadratic formula. How do I see where this comes from the quadratic formula?
Shall I see it?
Okay, so, right? There's sort of a y here, right? Which is that the zeros, remember, if we want to solve for 0, we use the quadratic formula. So we know the zeros of q of x are at x is negative b plus or minus the square root of b squared minus 4ac all over 2a, right? Let me rewrite that as negative b over 2a plus or minus this jump. You guys with me that this is the same formula? I just haven't combined using the common bottom that's here.
That's supposed to be a cube.
Yeah. I have crappy cubes, sorry.
Is there a reason why you're not combining the 2A?
Yeah. So the reason I'm not combining them is that I'm thinking about symmetry here. So when I'm drawing these parabola pictures, they're not symmetrical by accident. They're symmetrical on purpose, and it's because there's an axis of symmetry in here. Okay? So this picture is symmetrical about this guy. And if those zeros happen, say here and here, these are negative b over 2a plus b squared minus 4ac square root over 2a, and negative b over 2a minus this business. Which is like, oh my god, what the heck is happening, right? But keep in mind, this thing's just a number, right? So one way I could think about this that would be maybe easier is to say, oh, well, I don't really care about what this thing is. This thing and this thing are the same, right? So let me just think about this as, this one happens at negative b over 2a minus a number, and this one happens at negative b over 2a plus a number, right? You see that? That really means, if I think about this distance, that's the number. Okay, see that? So what's the middle? Yeah, the middle's just negative b over 2a. There's nothing magic happening here, actually. You guys see that? It's just a thing about symmetry. It's saying, okay, if it's symmetrical, then those distances are equal. And if those distances are equal, and they look like this, then they must each be the number. So the middle has to be negative b over 2a. You see that? Kind of? Okay, so that's why this, right? It's the zeros are at these points, and the graph is symmetric. And I can't spell the word symmetric properly because no one can, so that stands for symmetric. There's too many M's in it or something. Cool? All right. You guys want to practice with one? Okay. So, find the vertex and ID it for g of x is 5x squared minus 4x plus 37. Give this a try, guys. Yeah.
Would it be easier if we just figure out the quadratic formula first?
No, definitely not.
Yes, right. I don't know. I'm just kind of confused.
So there's a tendency, right, to try to find the zeros of this first. This thing might not have zeros. They might be complex. This symmetry thing still works. It's kind of crazy, but it still works. So really, all I need to do is find A and B and calculate this. That's a lot easier than jamming on the whole quadratic formula.
Okay.
That makes sense? So what I want you guys to take from this lecture is this thing and this thing.